A system design interview is a type of interview used by tech companies. It is a crucial part of the hiring process for many technical roles. It tests a candidate's ability to design complex systems. This means understanding how to build scalable, efficient, and reliable systems that can handle large amounts of data and traffic. Imagine being asked to design a popular app like Instagram. You would need to consider various aspects such as user interface, data storage, and how to handle millions of users simultaneously. Or a ride-sharing service like Uber. Here, you would need to think about real-time location tracking, matching drivers with passengers, and ensuring a smooth user experience. These interviews aren't about writing code. Instead, they focus on your ability to think critically and solve problems at a high level. They are about your thought process. Interviewers want to see how you approach a problem, break it down into manageable parts, and come up with a viable solution. You need to think about how all the parts of a system work together. This includes considering the interactions between different components, potential bottlenecks, and how to ensure the system is robust and scalable. System design interviews are becoming more common. They are an essential tool for companies to assess a candidate's technical and problem-solving skills. Many companies use them for roles like software engineer and solutions architect. These positions require a deep understanding of system architecture and the ability to design systems that meet specific business needs. Preparing for a system design interview involves studying different system architectures, understanding trade-offs, and practicing designing systems from scratch. It's also important to communicate your ideas clearly and effectively. Being able to explain your thought process and justify your design choices is crucial. With the right preparation, you can excel in a system design interview and secure your dream job in the tech industry. System design interviews help companies find skilled engineers. They want people who can build scalable and reliable systems. These systems should handle lots of users and data. A good system design is important for a company's success. It can impact the user experience, the cost of development, and the ability to grow. By doing well in these interviews, you show that you can think critically. You also show that you can solve complex problems. Preparing for system design interviews is crucial. You need to study and practice to feel confident. Start by understanding basic concepts like scalability, reliability, and availability. Learn about different architectural patterns like client-server, peer-to-peer, and microservices. Familiarize yourself with common system design concepts such as load balancing and caching. Practice designing real-world systems like a social media platform or an e-commerce website. The more you practice, the better you'll become at tackling these challenges. To excel in system design interviews, it's vital to have a strong grasp of essential concepts. These concepts are the building blocks that will help you create robust, efficient, and scalable systems. Without a solid understanding of these fundamentals, it can be challenging to design systems that meet the demands of modern applications and user expectations. These concepts form the foundation of system design and are frequently discussed during interviews. Interviewers often test your knowledge of these principles to gauge your ability to think critically and solve complex problems. Mastering these concepts will not only help you in interviews, but also in real-world scenarios where system design is crucial. One crucial concept is scalability. Scalability is essential for systems that need to grow and handle increased loads over time. Whether you're dealing with a growing user base or expanding data requirements, understanding how to scale your system efficiently is key to maintaining performance and user satisfaction. Scalability refers to a system's ability to handle increasing amounts of data and user traffic. This involves designing systems that can expand seamlessly, whether through vertical scaling, which involves adding more power to existing machines, or horizontal scaling, which involves adding more machines to distribute the load. Another key concept is reliability, which ensures that a system operates consistently and without failures. Reliability is crucial for maintaining user trust and ensuring that your system can handle unexpected issues without significant downtime or data loss. Availability focuses on ensuring that a system is accessible to users when needed. High availability is often achieved through redundancy and failover mechanisms, which ensure that even if one part of the system fails, the overall system remains operational. Understanding these core concepts will provide a solid base for tackling system design challenges. By mastering scalability, reliability, and availability, you'll be well equipped to design systems that are not only functional but also robust and efficient. These principles are the cornerstone of effective system design and will serve you well in both interviews and your professional career. Section 5. Data Structures and Algorithms, your toolkit. In this section, we will delve into the essential components that form the backbone of efficient software development. Data structures and algorithms are fundamental to system design. They are the building blocks that allow us to create software that is not only functional, but also efficient and scalable. They are the tools you'll use to build efficient and optimized systems. Without a solid understanding of these concepts, it becomes challenging to solve complex problems or improve the performance of your applications. Familiarize yourself with common data structures like arrays, which are the simplest form of data storage and are used to store elements in a sequential manner. Linked lists, which allow for efficient insertion and deletion of elements. Stacks, which follow a last-in, first-out, LIFO principle. Queues, which follow a first-in, first-out, FIFO principle. Trees, which are used to represent hierarchical data, and graphs, which are used to represent networks of connected data. Understand their strengths, weaknesses, and use cases. Each data structure has its own advantages and limitations, and knowing when to use which one is crucial for effective problem solving. Algorithms are step-by-step procedures for solving problems. They are the recipes that guide us through the process of performing tasks, whether it's sorting data, searching for information, or optimizing resources. Study sorting algorithms like bubble sort, which is simple but inefficient for large data sets. Insertion sort, which is efficient for small data sets, and merge sort, which is more complex but highly efficient for large data sets. Learn about searching algorithms like linear search, which is straightforward but slow for large data sets, and binary search, which is much faster but requires the data to be sorted. Mastering these algorithms will enable you to handle data more effectively and improve the performance of your applications. Section 6. Design patterns, tried and tested solutions. Design patterns are reusable solutions to common software design problems. They provide proven approaches to designing flexible and maintainable systems. Study popular design patterns like Singleton, Factory, Observer, and Strategy. Understand their purpose, structure, and how they address specific design issues. Knowing these patterns will help you design robust and scalable systems. It will also demonstrate your understanding of software engineering best practices. Section 7. Common System Design Interview Questions. System design interviews typically involve open-ended questions. These questions assess your ability to design real-world systems. You might be asked to design a social media platform, a video streaming service, or a ride-sharing application. Other common questions include designing a URL shortening service, a web crawler, or a distributed cache. These questions aim to evaluate your problem-solving skills, creativity, and ability to design scalable and efficient systems. Section 8. Architecting your solution, a step-by-step approach. When faced with a system design question, it's important to approach it systematically. Start by clarifying the requirements and constraints. Break down the problem into smaller, more manageable components. Define the system's architecture, including its components and their interactions. Consider factors like scalability, reliability, and performance. Choose appropriate technologies and data structures based on the requirements. Section 9. Communicating your design, Clear and concise. Effective communication is key in system design interviews. You need to clearly articulate your design choices and thought process. Use diagrams, flowcharts, and other visuals to illustrate your ideas. Explain your reasoning behind choosing specific technologies or architectural patterns. Practice explaining your designs concisely and understandably. The ability to communicate your ideas effectively is crucial for success. Section 10. Practice makes perfect. Mock interviews and resources. Practice is essential for mastering system design interviews. Engage in mock interviews with peers or experienced engineers. Utilize online resources like LeetCode, HackerRank, and System Design Primer. These platforms offer practice problems, solutions, and insights from industry experts. Regular practice will hone your skills, boost your confidence, and prepare you for the real interview. Section 11. Conclusion: your journey to system design mastery. Mastering system design interviews is an ongoing journey. It requires continuous learning, practice, and a passion for building robust and scalable systems. Embrace the challenge, seek feedback, and learn from your experiences. With dedication and perseverance, you can excel in system design interviews and advance your software engineering career. Remember that the journey itself is valuable, and the skills you develop will serve you well throughout your career.